For centuries, black holes were only imagination, objects so dense that even light could not escape. They existed in equations, not in telescopes. Many scientists doubted they were real. Today, black holes are no longer theory. They are photographed, measured, and heard across the universe. But what actually is a black hole? A black hole forms when a massive star runs out of fuel. Without energy pushing outward, gravity wins. The core collapses violently, crushing matter into an unbelievably small space. What remains is an object so dense that space-time itself caves inward. At the boundary of a black hole is the event horizon. Cross it, and nothing returns. Not light, not information, not even time behaves normally. Inside, gravity stretches objects into long strands in a process called spaghettification. Space and time swap roles. Forward becomes inward. Escape becomes impossible not because of speed, but because space-time itself flows toward the center. For a long time, black holes were invisible. We could only detect them by watching nearby stars move strangely, orbiting something unseen. That changed history. In 2015, scientists detected gravitational waves from two black holes colliding. Space-time itself rippled as they merged. It was the first time humanity heard black holes instead of just imagining them. Then in 2019, we saw one. The first image of a black hole in galaxy M87 revealed a glowing ring around a dark shadow. It wasn't just a picture. It was proof that Einstein's relativity works at the edge of reality. Later, in 2022, we imaged the black hole at the center of our own galaxy, Sagittarius A star. 4 million times more massive than the Sun, sitting quietly at the heart of the Milky Way, controlling the motion of billions of stars. We also learned black holes are not cosmic vacuum cleaners. They don't suck everything in. From far away, their gravity behaves like any other mass. You could orbit a black hole safely, as long as you stay outside the event horizon. Another shocking discovery is that black holes are not eternal. Stephen Hawking showed they slowly leak energy through Hawking radiation. Over trillions of years, black holes evaporate. Even the darkest objects in the universe are temporary. We now believe almost every large galaxy contains a supermassive black hole at its center. These monsters shape galaxy formation, control star birth, and influence cosmic evolution. Black holes are not destroyers alone. They are architects of galaxies. Some theories go further. Black holes may hide quantum gravity. They may connect to wormholes. They may store information on their surface. The famous information paradox asks whether anything truly disappears inside them, or whether the universe keeps records in ways we don't yet understand. Black holes sit where physics breaks. General relativity works. Quantum mechanics works. But together, they fight. And black holes are the battlefield. So what do we actually know? We know they form from collapsed stars. We know they bend space-time extremely. We know they collide and shake the universe. We know they evaporate slowly. And we know they sit at the centers of galaxies. What we don't know is what truly happens inside. A black hole is not a hole in space. It is a region where space and time are rewritten. Every discovery about them teaches us not just about death of stars, but about the structure of reality itself. Black holes are not the end of the universe. They are the questions the universe asks about itself. And every time we observe one, we get closer to understanding how existence really works.